right, my friends, welcome back to the Rheia build project. Framing is over. It's time to put all these little ducts in, and we got other pipes as well. This is the mechanical episode. We're gonna jump into HVAC. We're gonna talk about fresh air and plumbing. We got a lot to cover. There's a lot of nerdiness on this episode. Don't worry, I'm gonna show you all the details. The Rheia build project in partnership with Builders First Source. Let's get going.
A Build Original Series, in partnership with Builders First Source. The Rheia Build.
All right, guys, exciting times. I love it when we get to the MEP phase, mechanical, electrical, plumbing. Now, every builder who's been around the block knows this, but we want to start with our big pipes and our big ducts first, and then we transition to our wires. So really, I like to start both the plumber and the HVAC guy at the same time. I want to make sure that there's not a conflict between a big duct and a pipe that only can be in one spot. So I really like them to start at the same time. We're going to start with the mechanical phase though. As you can see, ready frames complete. We rocked through that process. We actually got the trades in much faster than I would have expected. I actually had to call the guys and get them in. And you saw earlier, we're running something a little bit different when it comes to the ductwork on the first floor. We're going to do a pretty traditional ducting system on the second floor, but this system, this gray pipe that you're seeing, is called Rheia Duct. This is a little different than what you've seen me use in the past. What this is this is a flexible duct. This is UL rated, and you can see it's non-insulated. This is only meant to be within the air-conditioned space of the house. And you might need to train your inspector. In fact, my inspector came by and talked with the Rheia rep and said, oh, okay, I understand how this meets code, because there is a bit of a misconception about needing insulated duct within the air-conditioned space of the house. This is approved to use though. So what you're seeing here is this HVAC closet, which by the way, got framed ahead of time, and I made sure my carpenters put the walls up first. We just used Fantech because we had some left over. Plywood would have worked as well. I like having that finish on first though. If you come back and put sheetrock in here later, it's really hard to do sheetrock in a mechanical closet. Plus, I don't want that paper facing in there. There could be some minor condensation. If a drip ever happened, I don't want it to hit that sheetrock. So having real wood in there works. I can also paint this before we actually put any equipment in. Now, here's the deal on this Rheia duct. You're noticing there's a bunch of them coming in. We're early in the process, but this is a standard Carrier upflow system. I need to check my tonnage. I think the first floor in this house is like 2.5 tons. Our friends at Energy Vanguard did the manual J, so we know the exact output. And then we gave that manual J to the Rheia folks, who gave us a full layout. And Jeff, my installer over here, has had his iPad out that shows the exact CFMs, the runs, and the locations. But what's cool about this is each duct, you can see one coming in the background, each duct is a home run. Meaning, just like your electrician runs a wire from that outlet and runs it all the way back to the panel box where the breaker is, this is similar. Each one of these runs is an uninterrupted duct from here to an outlet. And in fact, let's go look at that one I just installed a second ago. That ductwork runs from the HVAC closet all the way to here. We're in the primary bedroom. And so there's no breaks in that ductwork, and it's going right to this section. We'll find Gabe in a second from Rheia to kind of show us the connections. But already what I'm liking about this system is it's, number one, really easy to fit through with the trusses. I mean, look at all that. Super easy to snake those through. I had a fairly tight opening above this doorway here in terms of the truss system, but no issue whatsoever bringing that Rheia duct through there. I mean, I had multiple outlets, multiple locations that I could have brought it through, and it made it really simple. Number two, the thing I like about this system is it's really easy to change later and to commission. I think that's one thing that really is missing on a lot of HVAC systems is that commissioning. Like after the system's running, let's make sure that it met the intent of the manual J. When Energy Vanguard gave me that manual J, they're telling me how many CFM goes in this bedroom, and then we need to verify, okay, if we called for 40 CFM into this bedroom space, what are we actually getting at the outlets? And this system is designed so that we can, number one, plan for the number of CFM, but we can also test and ensure and balance later really easily to make sure we've got what we need in here. Now, I mentioned the HVAC closet over here. We do have another system going on in our attic. Let's actually change gears and let's go upstairs. We haven't started upstairs yet, and I want to show you something that's really interesting, so I'll meet you upstairs. Okay, y'all, second floor. This is a really nice space. We've got 2 kids' beds up here, is kind of what we intended, but frankly, they're big enough. They could be your master bedrooms up here, if depending on the use case. You might have 3 adults living in this house. These are really nice bedrooms with their own suites. We also have this giant family room, but on this mechanical episode, what I wanted to show you was this right here. I'll be honest, I've been a bit of a, I don't know if hater is the right term, but I've been a little of a snob, that's probably the best way to say it, on hand-cut roofs. I put a lot of hand-cut roofs in. I have not done a lot of trusses. We truss roofed this house, and I said to the truss designer at BFS, I need a really open space. I want storage trusses, and I've seen storage trusses, but check this out. Let me turn my little GoPro on here, and let me show you this space. And look at this. I mean, this attic is ginormous and very open. So we got collar ties up here. We've got 2 sheets of Fantech, so we're at least 8 feet wide, and I forget the distance on this house. I don't know what it is, like 36 or 40 feet long. So from that wall through this attic access to this wall, 40 feet. The HVAC installers, Jeff and his crew, we're gonna either go to this side or this side and keep that equipment kind of hugged up, which means we're gonna have a ton of storage up here. And this is part of the air conditioned envelope of the house. So that means all this HVAC equipment, the ductwork that's in here, will all be within the air conditioned envelope, of course. Now up here, we're gonna do some standard ductwork like we've done in the past, a mixture of some metal on the supply side, probably mostly flex on the return side. Again, we're trying to, I've said this earlier, but we're trying to build this house on a more modest budget than what I've done in some of my other projects to make it a little bit more attainable. So this system up here, this Carrier, will be a horizontal mounted system with slightly more kind of standard ductwork, so to speak, done in a way that's smart, airtight, but also with budget in mind. So I wanted to show you that space. With that being said, let's actually switch gears now and let's go see if we can find Gabe, the Rheia rep who's on site, and show us a couple more details on that ductwork downstairs. Okay guys, now one thing I want to point out that's worked incredibly well as we think about mechanicals in this house is right above my head. These open web trusses that we designed with Builders First Source. You know, in the past, we kind of hope that everything works out. We put a knockout in for a trunk line, but what we did with digital tools and with their team is we actually modeled, if you watched that previous episode, where everything was gonna go. So we had a meeting with both my plumber and my mechanical guy at my office. Steve Basic helped us kind of wrangle the team, and we figured out, okay, where are these plumbing and mechanical vents gonna go in this house to make sure that we don't have conflicts in the system. And I gotta tell you, it's worked out incredibly well. So just to point out a couple pipes, see that big silver pipe right there? That's my exhaust fan from this guest bath, home office bath, right on the other side of this wall. And that's running over my head and right out that gable. And look how that just snaked in there perfectly. Another pipe that we modeled that's worked out absolutely perfectly is this right here. This is catching the upstairs. You can kind of see it above my head here. It's catching the upstairs. Actually, let's walk around the corner. It's catching the upstairs toilet right there. We drilled that hole for that toilet. And then as you slide overhead here, you can see that toilet's draining into this line here. And then it's also venting above me. And then it's coming down on the other side of this wall right here is that down pipe. And all those were modeled ahead of time. The big thing about this is that BFS did some conflict resolution for us. They call it collision detection. And that collision detection at first had like, I forget what, like 60 or 70 collisions or things that we were worried about. Like, hey, this is structural wood that we can't eliminate, but we also need room for this pipe. So how do we fix that? This is incredible, guys. This is totally the game changer and has made this house just go together perfectly. So big thanks to all my friends at BFS that helped with that. We had 2 or 3 people on their team, from the modeling folks to my sales rep, who helped with that process. It's worked out incredibly well. All right, guys, let me introduce you to Gabe with Rheia Duct. Gabe, gosh, there's so much to talk about here, but let's start with the planning process. You know, Energy Vanguard did the manual J for me, and I provided that to you guys, and then your crew actually does the engineering to figure out what ducts and where. What does that look like?
So we follow a thoughtful design process, and what that means is we'll take them through RightSoft, and we'll go through an actual design with Rheia and our Rheia plugin through RightSoft. So we have our third-party designers that do that work for us, and what they'll do is they'll go through and they'll put these ducts in conditioned space, and it'll spit out a manual J. We still follow all the same design parameters as a conventional system, and that manual J will spit out these duct runs in conditioned space. And so with those duct runs in conditioned space, we could then predict each run's length, pressure drop, and CFM.
Okay, so let's use, for instance, maybe this den on the first floor here, which is a guest room or maybe a home office. We called it a den on the plans. Let's use that as a for instance. Talk to me about what the program's spitting out for that room.
All right, so what the program will spit out for that room is a design calc file. And in this design calc file right here, you're gonna see your velocities. So for the den, for instance, we can see right here that we have 35 expected CFM on that run at a 4-inch diameter duct, and that's 386 feet per minute. So our velocity is not outside of your conventional system. We're not a high pressure system. We're a low pressure, low static system. And the damper position we're expecting to have on these ceiling boots right here is 2 in that position right there. Gotcha. And that's a 38-foot run.
And that's expecting to be a 2 with a 38-foot run. But I think what's interesting, and we'll have to capture this later, is that each one of these outlets has a damper that's movable. We're gonna set it for a 2, but when we come to commission the job, we're gonna put a flow hood on there. And if it needs more CFM to meet that, we could actually change that damper position,
Absolutely. Right? So through the Rheia Verify process, we'll come in and measure that airflow, as you mentioned. When we measure that airflow, we could compare it to the target, and then we'll enter the measured, and it gives us our delta, and we'll know where to place that damper position.
That's pretty cool. And another thing I want to mention here that Gabe mentioned that I don't want to gloss over, it's not a high pressure or a high velocity system. This is standard velocity Carrier. I think the manual J called for a 2.5 ton Carrier.
2.5 ton.
I usually think of a ton of air conditioning, heating, and cooling being around 400 CFM. So this unit's what, 1,000 or so CFM?
We're gonna probably be about 1,050 CFM on this unit with 21 total supplies. Now 20 of those supplies will be in the conditioned space. One of them will be in the attic as a conditioned attic.
Got it. So in other words, this is a standard Carrier system that you would use anywhere. This isn't something special that Carrier is making with Rheia. And of course, Carrier sponsors this episode, but Rheia works with all manufacturers. I mean, this could be worked with a Trane, with a Mitsubishi, with any other flavor, vanilla, chocolate that you want out there besides Carrier, right?
Absolutely. We're agnostic to equipment. We can work with any manufacturer.
That's pretty cool. While I got you, Gabe, give me a quick rundown and kind of a tech look at a particular run. I installed one on camera earlier, but if you could talk me through it, that'd be great. So starting with the boot that's on, or I guess we'd call that a boot, right?
Yeah,
on the
that's
ceiling.
a ceiling boot right there.
So does it come with that hanging bars already on that already?
So those are 2 individual SKUs right there. That's our ceiling boot as one part of our SKU, and that's our hanger bar. That's a proprietary bracket that snaps onto the sides of that ceiling boot. And that ceiling boot right there can be hung on the side of it as well. You'll see some mounting brackets right there. That can be used without the hanger bar in certain applications.
Okay, and then the duct work itself, let's show this as an example. This is not insulated, which I had to wrap my mind around for a minute, to be honest. When I first saw this on a job, I was thinking, how could this work? I mean, this is uninsulated duct. Isn't that just the standard crappy flex duct that I use and see builders using for, let's say, exhausts, right? This is totally different than that there, isn't it?
Completely different. So this is a duct system. It could be any length. It's a UL 181 rated duct. So what that means is your conventional duct gets its UL 181 rated from its complete assembly. So as a complete assembly, 181, this uninsulated is 181 without that insulation jacket covering it.
That's pretty cool. And I do want to mention though, because it's uninsulated, this is only intended for use inside your conditioned envelope, right? Don't put this up in your hot unconditioned attic, right? Your ventilated attic. This needs to be within the same AC envelope that you and I live in.
Yes, absolutely. So we want to stay away from exterior walls, stay within the conditioned space of the home, and you'll be just fine.
Now, one thing that blew my mind on this is that when I visited a job that had Rheia, I didn't see tapes or mastics being used. Explain to me how you guys get an airtight connection on this.
So we have no duct tape, no mastic, no zip ties, no screws. We'll take this threaded component right here, one of our only threaded components in the system. This is the 4-inch ferrule. We've got a 3-inch ferrule. This threads onto the duct, creates an airtight seal, nice and tight. And then from here, everything is a snap fit connection. So it's a friction fit through our plastic components. These are an ABS plastic.
Okay.
We'll make the connection just like this, and you've got a 45 right there.
Did you hear that snap, by the way? That tells you that it's connected,
That's
right?
the Rheia snap right there. So you'll get that nice click. You know you're connected. You know you got an airtight seal.
Wow.
We also have the sealing boot, which you have up here. We make sure that damper's wide open when we do the install.
Okay, so this is that damper right there, and you can see the position numbers if you look close in there. And then how's that snap in?
So the way this works is when you've got this mounted up inside your ceiling, this will just snap on like that, and now you've got a almost completed assembly back to the plenum.
That's amazing. And you guys, I suspect, have duct blasted this. How much loss are we talking? Are you seeing 10% loss, 5% loss?
We're seeing about a 2% total duct leakage in a home outside of the equipment.
That's impressive, y'all.
Yeah.
It's hard to get to 2% with the standard system. You gotta have a lot of tape and mastic. So for you guys to get 2%, that's impressive. And the last thing I want to mention, I think it may have been hard to see on camera, but as he put this fitting in, there's barbs or like screws. It's almost like you're screwing it on into that to make that connection. And now that I see it up tight, boy, you can see why that's airtight. That is impressive. And you can also see, if you look down in there, it feels like the air is directed where it wants to go by the inside of that fitting. That's really neat. This is an impressive system, Gabe. I like it.
Thank you.
What did I miss on this install? I mean, you guys are just about done, and we're like, what, 4 hours in on this?
You know what, we've got one last connection over here. That'll be the last one. So 4 hours with training, we've been able to do a great job here on this install.
4 hours on a 2.5 ton zone on this entire first floor, which, by the way, snaked through all these trusses. That's very fast.
That's right.
Hey, Gabe, how about we do this last connection together?
Sounds great to me.
All right, so the last one we've got, I believe, is in this guest room right here. It gets actually right above the toilet in that
Yep. So we'll go ahead
bathroom.
and get this duct pulled all the way in here.
So your ceiling boot's in place already. All we got to do is snap that duct on and then run this in a home run fashion back,
That's right. So let me grab this ladder.
Okay. While you're going to get that, tell me how much strapping is needed on this system.
So strapping is per code every 4 feet.
Okay.
So whatever the code requires, we're not outside the code. If the code was 3 feet, we'd fall 3 feet, but for this application, I believe it's 4 feet.
Okay, so he's just popping on that ladder.
So up here, you'll notice we've got that 45 already installed.
Yep.
That'll make our nice clean transition here to keep our static in line.
Kind of like a street 90 right there.
That's nice and tight. And I'll pull up this side of the duct.
And then here's the end right there, brother.
Yep. Thank you, Mike. Matt.
There we go. And we grab that out. And then this is kind of nice to have a second person working with you, because now you got one person in the ladder and then another who's going to feed it up.
That's right.
And I'll grab the end, and all we're going to do is snake this around. And remember, the model called this for 38 feet. But if we run into problems and we do 40 feet or even 45 feet, it's no big deal, because we can commission this at the end and we're putting that flow hood on.
That's right.
That right?
Yep. At the very end of this, we'll go ahead and commission this. We'll measure that airflow, and that damper will be adjusted per the software to tell us where it needs to be to meet the design of this home.
You know, it kind of reminds me a little bit of the Zender system that I put in my house that I was shocked about when it came to this home run system. I called it shop vac tubes because it makes sense to me as a contractor. You know, shop vac plugs into the unit and then plugs in at the actual device you're going to use to do some vacuuming. This is kind of that same system. It runs continuously between the two. I'm falling down on the job, brother, sorry.
Nope, it's all good.
And you can see how quick it is. Gabe's just snaking it through there. There you go, nice. Do we need to, as we're pulling this, do we need to be cautious not to cut the duct or harm the duct as we're pulling it?
So this is a reinforced fiberglass duct. It's pretty strong. Really, the only thing we're concerned with is any kind of nail plate or any kind of nail strap that might cut it, but usually we'll stay away from those if we can.
Talk to me about crushing. I mean, it feels like this metal wire that's in there is pretty strong, and it would be tough to crush a duct like I've seen with some flex that are shoved into some places.
When you're running these ducts, sometimes it happens where they're right behind you on your feet. You might step on them and you crush it a little bit, but you can kind of smooth out this wire helix, get it right back in place. But being that this is a 181 product, it's got to meet certain crush test rating.
Got it.
So it'll bounce back to a certain percentage of its original shape.
Okay.
The same is true for our components as well. All of our 181 components, A and B and UL 181C, have that same crush test rating.
Yeah, and just like any flex duct though, we don't want to see this looping around in places, right? We want nice tight duct work. We want to make as little resistance inside that duct as possible to get the max airflow.
Yeah, really our goal is to make it look like rigid pipe. Even though it's a flexible duct,
yep, we want to get it as tight as possible and as much like rigid. Yeah, I mean, look at these ducts these guys have stretched out and pinned. Those look really nice.
We'll get this last end right here.
Yep. This really shows the power of your system. That's a tight-ish connection right there through the system, through the truss system, I should say. And look how easy that is to get through. That's nice. And we're also strapping right here at the end, getting those nice and tight. Now we're gonna have access to these ducts in the attic above the family room, but in this truss area, once we get sheetrock in, there's not gonna be access to these. So I do wanna mention, I did ask these guys about cleaning the ductwork. Could we clean these? And absolutely you could. You're gonna use something that kind of looks like a, what am I trying to say? The cleaner they use for laundry rooms. For
vent cleaners.
A vent cleaner, yeah. That's right. For a dryer exhaust type cleaner. A spiral type device that's got a brush in there. You could clean these in the future.
Yep, absolutely.
Gabe, thanks so much for coming out.
Thank you so much.
We're gonna let the guys finish up the job and we'll keep going on this mechanical episode. This Rheia Duct system, really interesting, but we got more stuff going on upstairs. I've got Eric on around here somewhere. Let's see if we can get Eric's take on this. Hey, Eric!
All right, Gabe, thanks a lot, man. That's some interesting stuff. We've got Wayne upstairs here. Hey, Wayne, how's it going?
Going great, buddy. How are you today?
Good, good.
Awesome.
This is an ERV from Life Breath.
Yes, it is.
Wayne, you came down from Ontario, Canada. That's where you're based out of. You've been working with Life Breath for a long time?
Yeah, just coming up to 30 years. Been in the field for basically all 30.
And you're doing a ton of training on equipment like this.
Ton of training, mostly technical, mostly install training, doing that all the time.
You like to say that the homeowner is the heart of the home, right?
Correct.
But you guys provide the lungs.
Provide the lungs, yes, we do.
All right, so let's get into that. This is an ERV, so It's a energy recovery ventilator, is that correct?
Yep.
And this is exchanging fresh air from the outside with the stale air in the inside. It's really the lungs of the house. It's providing quality indoor air for the entire space.
That's correct.
Now this is a larger home, so there's actually going to be 2 of these in this house?
2 systems. So we have 2 separate air handling systems in this house. So we're going to put an ERV on each one. Gives us better zone control and gives us better control level to level.
Okay, so you're not going to use and rely on one ventilator for both levels of the house,
Correct.
Basically. Okay, so that's really cool. So how is this going to get piped into the system overall? I know we've got an attic up here. We see a lot of ductwork around us. They're currently installing the HVAC system in the house right now.
So basically what happens is the HVAC system goes in as usual, as normal. The systems going into this house are called a Simplified System. We're just going to take stale air out of the return air, and we're going to take and inject fresh air back into the return air of the system. It then goes through the air handler, gets delivered to the house.
So if any conditioning needs to be done with that air at all, although it's even temperature and humidity, it's going through the air handler and you're utilizing the ducting system and the air handler too to push this throughout the house?
Correct.
Okay, so what about filtration or anything like that? Is there any special considerations when we bring air in from the outside?
So basic ERV we can do some internal filtration. Actually, I can show it to you.
Okay.
So we have internal filtration here. It's pretty basic. We can upgrade this. I recommend if you're doing in-home filtration, you use a separate system.
Yeah, so we're going to
more
have that on the
efficiency.
air handler anyway,
Correct.
right?
Yes, absolutely.
So you've got a MERV 6 here. You can upgrade this a little bit, I would imagine, maybe to 8 or 13.
We can actually go right to 13.
Really?
Yep.
Okay. So color coding on this is pretty cool. So I'm guessing, not familiar with your particular model, that these are coming and going to the outside because they're blue.
That's correct.
Cold.
And the reds are the
From
inside.
a cold climate, makes sense, right?
Yeah, yeah, absolutely.
Okay. And then, so you've got 2 fans in this, and the air is actually exchanging through this removable core, right? So
Yeah.
this big box right here is the core where we've got the air going through in multiple directions.
Correct. So if you just look at it from the point of view of you've got multiple plates.
Yeah.
You've got the inside air on one, or the bad air on one side, good air on the other. We're doing a heat transfer across the plate. We're doing a moisture transfer through the plate. If you just picture a Gore-Tex jacket which wicks moisture away from your skin, that's exactly what we're doing in here.
Really? That's interesting. So you're not actually changing or removing humidity. It's equalizing through this core.
Yeah, so nature's always trying to equalize.
Yeah.
So when you have an indoor environment that's cool and dry, an outdoor environment that's hot and humid, the humidity is going to naturally want to migrate to the drier side.
How do you control this then?
So there's a number of different ways we can do it. We can do it without a control.
Okay.
If you have a thermostat or a fancy IAQ, we do have a couple of relays you can access to make it do stuff. You're going to get the maximum amount of control, all of the options with something like this. This is our deluxe control, and it'll give you every feature and function that the unit will give.
Okay. So when it's simplified and it's piped through the air handling system, through the ducted system, is there like a boost function we can access or anything, or is that only if we're going straight to outlets in the space?
You can always use a boost function.
Okay.
It's on here. You can do a wireless or a wired timer in a location if you want, and that will boost it usually from speed 1. These are 5-speed units, so this is going to go from 1 to 5, which is boost.
Okay. Okay. And then with that simplified system, typically what you're recommending, I would imagine, like I have in my own home where we're running these 24/7.
Yeah.
Okay. What
That's
is the
the best.
advantage of that?
That just means, so we're literally in a bag here. We're in a very, very tight house. Gives us, the tighter the house, the better it is for control inside.
Yeah.
Because nothing's coming in. You've got full control. We are injecting fresh air into the building 24/7. We're always getting our fresh air. That is important because it's not coming in anywhere else. When these are set up, we set them up for the occupants in the space, so you're getting exactly the right amount of fresh air that you need in the space.
Okay, so key thing you said there was exactly the right amount of air. Now that interests me because when this is closed up, you've got this nice insulated enclosure here. You've got no drain for humidity, for removing water or anything like that. How do you get the exact right amount of air when I don't see any way there's no dampers in here?
So
like there's a fan here, but I can put my hand right in there. There's no damper.
No damper.
Where I'm used to seeing a damper for balancing. How is this getting balanced, leading to that exact right amount of air?
Okay, so this is got ECM motors in it, so highly efficient. We also have auto balance with these. ECM motors are fabulous. First of all, they don't use a lot of energy. Second of all, we can do lots of different control with them.
So you can ramp them up, ramp them down,
ramp them up,
like that.
ramp them down. So what happens with auto balance is now through the control, we are going to set it up for the CFMs for each speed. So
Okay.
speed 1, for example, in a 3-bedroom house, normally we set that up for around 60 CFM. So we're going to dial this in for 60 CFM.
And this particular unit, not that it's important for this video, but this is like a 100 CFM model.
This is
correct?
actually 180 CFM.
180
Yeah.
CFM. Okay.
Yeah.
So that being with the multiple speeds, you're saying 60 on the low end. What's the high end at 100? 180.
180.
There you go.
Yeah.
And so the balancing is done through just pressure differential?
Correct. It's the
Okay.
actual live airflow measurement inside, and then the control tells us what the airflows are. We can just balance them down to each other.
All right. Now I know it's like 9,000 degrees Kelvin in Austin, Texas right now. I guess because of the humidity is super hot for this Minnesotan. But I live where it's a heating season for 7 to 8 months of the year.
Yep.
Okay. And so knowing that, you also understand that it gets very cold at certain points. And the system I have in my own house actually has to be shut down in the wintertime at certain temperatures, right? Do you have to do that with yours, or how do you handle really extreme cold temperatures with an ERV? Because that's one of the reasons why a lot of people might think that an HRV is better in cold climates than an ERV, but that's not necessarily the case.
Okay, so I've been with Life Breath for 30 years.
Yeah.
For the first 25 of them, I would have never recommended an ERV in your house, ever.
Okay.
Technology has changed. The defrost cycles are much better now. The cores have improved. Now we're getting excellent performance at minus 25.
And that's because you can like divert air through the core different ways based off of temperature?
No, it's actually just based on the core itself and defrost.
Really?
Yeah, our defrost has got great control. When I talk to the other old guys in my company, we're hard pressed now to find a location for an HRV over an ERV.
Interesting.
Yeah, like in your house, for example, you said you've got great improvement with the ERV versus the HRV.
I have.
HRVs, we've struggled with drying the houses out, humidification, all of those things. The ERVs tend to modulate the humidity in the house a lot better than they used to.
Yeah, no, really. It's honest with the HRV in my climate, whether it's been cold or in the humid summers, I haven't seen the spikes or drop in humidity like I did with the HRV. It's evened it out, and it's a lot better that way.
Yeah.
Well, it looks like you guys have really thought of everything. I know they're kind of waiting on this unit to get installed. I want to thank you so much. I have more to go film for this episode.
Okay.
It's been awesome learning about this. Thanks, Wayne.
All right, thanks, guys.
All right, so those are the lungs of the house. What in the world is this? This is a big silencer. Well, if there's one of these, it means we're going to be moving a whole ton of air. There must be some exhaust fans going on. Who's working down here? Oh, my buddy Jeff. Hey, Jeff, how you doing, buddy?
Hey, how are you?
Good. What are you working on over here?
I'm installing these, it's a remote Fantech blower exhaust system. It's for 2-to-1. It blows from, it's a remote blower, so you don't, for noise reasons.
Okay.
And also you can get more area. It's not for one, like ceiling mounted.
So this is I'm standing in a shower area. We're in the primary bath, and I saw there's 2 of these in the ceiling. What you're holding to me, though, doesn't look like an exhaust fan. So you've got a remote blower, like you said, and that's going to actually be ducted to both of these exhaust fans?
Yes, that's
in the ceiling.
That's the joy of it. There's this one that's in the wet area of the shower, and there'll be another one in the water closet.
Kind of like what we see on commercial buildings where they can collect from multiple places, have one remote fan. Having that fan in the other room, though, eliminates having the noise in the space.
Yeah, very much so.
So that's an advantage.
Very much an advantage.
Okay, so then also you don't have to have individual switches. If you need 2 fans in one room for some reason, you don't have to have multiple switches.
Yeah, you don't have to butterfly them. I mean,
Okay.
daisy chain them. You can just have that one blower.
Interesting. So are they doing this throughout the entire house?
They are doing this particular in this house is just for the master area, and then they're using the conventional ceiling mounts in the kids' restrooms and the laundry and whatnot.
It's pretty interesting because then you're just leaving this remote fan going straight outside with it. Really normal operation.
Yeah, it's great. Yes, it's the benefit on this is really for the noise.
Really?
Yeah.
That's very cool. How does it trim out? Just looks like a regular fan then?
I have the fitting. I'm not sure where.
Oh, here's one right here.
See. Well, you
All right.
see, like this even has a gasket, or shouldn't have a gasket. Usually, for its slide, they have. You'll see they have the support that slide through for support. Sheetrock level here,
And then you've got just a trim piece there.
and then it just pops in.
This one actually looks like it has a
And it's-
spot for a light bulb.
That's the cool part too. You
Really?
have a light.
Interesting system. This isn't the only bit of Fantech though throughout the house, is that correct?
No, it's not.
are
Actually,
they
there's
doing?
quite a bit of Fantech here.
What else are they doing in the house that is Fantech?
Well, see, on the other bathrooms, other than the master, they're having regular ceiling mounted Fantech units in the kids' rooms, the laundry, powder, etc. And then, of course, there's going to be the Fantech makeup air system,
Okay.
which is
Oh, for like a kitchen exhaust.
for exhaust. Yes, it's powered.
That must be what I saw, that big silencer.
Exactly what that silencer is, because that
Interesting.
makes a lot of noise. And then there's also the kitchen exhaust. The liner is Fantech, as long as it's going to have a remote blower along with that silencer.
Stuff, Jeff. There's a lot going on here, so I'm going to go take a look at that. Have a good day, man.
Hey,
That's pretty cool. I'm looking for Justin. Justin, how you doing, buddy?
Hey,
All right, man.
Eric, good to see you.
New
bud.
Carrier system coming into this house. There's a whole
Yes,
bunch
sir.
going on. The garage is going to have a mini split. There's going to be an air handler up here, like a 2-ton system.
Correct?
2.5 ton on the main level,
Yes, sir.
but it's all new technology.
Absolutely. Yeah, this is pre-release, so we can't talk a lot of details, but what I can tell you is it's fully inverter. It's going to turn down to 25%, so you're going to get that fluctuation in capacity so you can leverage all those advantages. You know, when it's 105, it's at maximum capacity, but most of the time, we're not operating at 105.
Okay.
I mean, that's less than 5% of the year. So you're able to turn down and take advantage of that variable capacity. You're going to have a form factor of a mini split or a mini VRF type outdoor unit, same form factor for both. This is
Like
actually
a side discharge unit.
Yeah, side discharge. It's actually mini split type technology combined with the best of a residential split system. So you actually have traditional line set from a residential system. You have a form factor on the air handler that's a multi-position air handler similar to what you'd have in residential, but then you get all those advantages in that form factor like we talked about with the outdoor technology that turns down. It's high heat capacity, so believe it or not, we have no heat strip in this house.
So yeah, down in Texas, you've got low ambient operation.
Yeah.
Specs on that will come out later, but you'll
Absolutely.
be able to go no heat strip at all. So auxiliary heat out the window, we're saving money on the install, saving money on operation.
Yep. And when we had the snowpocalypse here in Texas and you watch people's energy bills go through the roof, it was that resistant heat that was doing that. So in this scenario, even in those temperatures, this thing would be pumping out and you'd be feeling roasty in here.
That's interesting. So you call it a crossover technology. So you talk about the air handlers that are going to go in here. They are Carrier air handlers.
Correct.
But you could pair this up with a gas furnace, maybe like where I'm at in Minnesota.
Yeah, you could pair it with the gas furnace. For multifamily applications, we can pair it with multifamily air handlers. We can also pair it with our traditional air handlers in our residential split line as well.
So you've got the technology that we're more familiar with when we start talking about mini split systems. You've got a lot going on there, inverters, you got a lot of efficiency and capability and flexibility.
Yep.
But you're more of a unitary installation with the air handler, typical line sets, outdoor unit, although side discharge.
Yep.
So that even lends a little flexibility just for location placement as well too.
Oh, absolutely. And one other detail that I can tell you about this is it has a 24-volt interface built into it.
Nice.
So we'll be using an Ecobee 6 on this, which is a control people know and love. You're able to use control platforms that you're comfortable with these products. There's a lot of flexibility with
Yeah, you're not stuck with some kind of remote control or some proprietary communicating system that you can't go down to Lowe's and replace in an emergency situation.
Exactly. And you get into higher end homes where they have automation and various features like that. It makes it a lot easier to tap into that also.
All right, Justin, I appreciate it. I can't wait to see this new technology once it's installed. Guys, I got somewhere to go. I got to be up in the attic. I'll see you there. All right. Matt said to meet him by the Santa Fe, but Matt's not up here. You know what? I bet you he's downstairs. Hey, Matt.
Okay. Here. Oh, Eric. Hey, Eric, do me a favor. Could you go grab us some lunch? Man, you've been working hard. I'll show them these guys at Santa Fe up here, all right? All right, cool. Okay, y'all, so this attic is above our family room space. A little tight to get in here. You can see I've got my little temporary internet cord going. There we go. Okay.
So, storage trusses as well from BFS, like my other main attic. This attic won't be quite as needed to get into, except for changing filters. Now, I've got a Life Breath going in over here, but then I wanted to talk to you about my Santa Fe. This house is getting 2 units. This is the smaller of the 2 units. This happens to be the 70 pint model. I actually have one of these in my house too, and this is a really nice machine because it's very low watt draw, but it adds a lot of dehumidification power to the house. Now, 2-story houses, I like 2 air conditioning systems. I also think in the South, you really need 2 dehumidifiers. We're doing something a little special with this unit that I haven't done before. You know, I've got that LG hot water heater. I think we've talked about that before, in a mechanical closet just for that water heater right off the laundry space. We're gonna have a louver door there. And I thought, you know, that water heater is gonna be taking the heat out of the air and supplying that heat into the water. The output from these Santa Fe's is hot dehumidified air. I thought, why don't we take the output of this and dump it into the closet where the water heater is? It makes a lot of sense to me. If that's going to be a slightly elevated space when it comes to heat, why not dump that heat somewhere where it makes a lot of sense and can be valuable? It's going to make the efficiency of that LG heat pump water heater that much more effective. So Jeff and the HVAC guys are going to do a bit of a split on this. The return side on this side is actually going to come from the return on the AC unit or the main HVAC system on the first floor. We've got kind of an open return on the base. So this is going to pull return from the base, just like just like the mechanical system. And then the supply is going to get a branch out of this. One of those supplies is going to dump into the plenum, meaning the supply side of the HVAC system. Now, when you do that though, you got to put a backdraft tamper on there. We don't want the force of the air going backwards on this dehumidifier. And then the other side, as I said, is going to go this direction. It's a little hard to see, but I've got not a gable truss. What am I trying to say? I've got a girder truss right here. So I've got some space to be able to take that AC, pardon me, I've got some space to take that dehumidified output from here and send that into my water heater closet. Now, one thing you want to know about these units that I really like is they have good filtration attached to them. Now, this is only really filtering the internal air, but this is what's keeping that coil clean and making sure that for the life of the unit that we don't have any problems with the coil getting dirty. So when we take this little filter out right here, you're going to see that this is a pretty easy filter to get a hold of. This is a 12 by, if I can read it, 12 by 9 by 0.75. So this is not a high MERV. I bet this is probably a MERV 7 filter, but this is going to keep this unit nice and clean. And again, this is only filtering air from inside of the house. So this is not going to get super dirty. I will need to get up here about every 6 months roughly to change this. Like all filters though, when you take it out per the manufacturer specs, take a gauge and see how dirty it is and keep track of that, because I might be not needing to change this for more like 9 months or 12 months. Every house, every air, everything's a little bit different. And so when a manufacturer gives you a recommendation like Santa Fe does, change that every 6 months, that's really going to be dependent on how dirty the air is in your house. And if this had a fresh air input to it, it would get dirty much sooner. I'd probably want to replace that every 3 months. I've got one more space on this mechanical episode that I want to talk to you about, so I'll see you downstairs. All right, y'all, let's close out this mechanical episode by giving you a quick tour of this upper attic. By the way, you can come see this in person for Build Show Live, but here's what we got. The guys did a great job up here. This is all my traditional rigid metal trunk line. We do have a little bit of flex in the system as well. The flex will quiet the system down. It's also frankly a lot easier and faster to run. But all the main lines you can see here are all metal that have been insulated on top of the metal. And what you can't see here is that they've done a really nice job of masticing all the joints. We're looking to make sure that if we do a duct blaster test on this, or when we do a duct blaster test, that we're less than 5% loss for the system. And then when you've got these rigid ducts like this, like that turn you see, that 90-degree bend, that's going to be so much better than had we run that in flex duct. This blue tape that you're seeing back here is where the Carrier system is going to live. We'll install that later on. You can see we're all ready to go. The guys also did a nice job of blocking off with some blue duct specific tape. I forget what they call this. This is basically tape that the raiders use to keep dust and junk out of the system. So that Carrier will get installed right here. The return side will be on this side. And then the other thing I want to point out over here, look at my Santa Fe 98H. That's looking awesome. This is the return side of the unit. So we've got one big duct here. This duct we're not using. This would be if we had a fresh air input. I've done a lot of those over the years, but I've kind of moved away from that as I've moved into ERVs. This is kind of cool. Look at this. It's like that car magnet you've got with your builder logo. This is how you block off the filter. And I do want to point out, if I can get this filter out here, that these filters are very large. This is a 2-inch pleated filter. Really easy to change, really easy to get it. And let's see if it has the MERV rating. Yeah, check that out. That's a MERV 13 filter. And this is a pretty standard size, 1.75 by 14 by 17.5. Also, just as a side note, make sure you put them in correctly. We want the airflow arrow to be correct. And we're gonna change that roughly every 6 months on this dehumidifier. Put the magnet back on. And then this is the supply side of the unit. I think we talked about this earlier, but just to clarify, this duct right here is going to the supply side of the furnace, which will help supply dehumidified air to the whole upstairs. And then these two ducts, which are rigid metal, I love seeing that, are gonna supply dehumidified air to both of these upstairs bathroom spaces. I did that in my house for the first time. I'd never done that before, and I absolutely love it. It dries out my bathroom showers for both my kids' baths really quickly, and that's just a terrific way to distribute that dehumidified air. Remember, the output of this dehumidifier is dehumidified air, but it's also hotter air, right? The compressor is inside that box, so think about your compressor outside, pushing that heat off into the atmosphere. This doesn't have an outdoor unit, it's all in one box as it dehumidifies. So the output air is a little bit hot, but also dry. So it's perfect to drop into, especially a kid's bathroom. And then let's end the episode down here. We're about, 80% complete on this Life Breath unit as I knock off some leftover duct work. This looks fantastic. We're mounted on the wall. The guys did a nice job putting an extra piece of Fantech up to mount this to. This will give easy service. And if we actually pop this open, you can see the guts right here. And here we go. So we've got two filters on here. This filter is filtering the incoming air. So this duct you're seeing right here is on the gable behind me, and this is insulated because we're bringing basically hot air in a lot of the times. We're in a hot, humid south. We don't want this to sweat. This is bringing the air in. And remember, we added that extra input filter. This isn't required, but man, is this nice to have. I'm doing this on all my units now. This little April Air unit right there is a big 3-inch wide pleated MERV 10 pre-filter. So that now this smaller filter, which isn't quite as aggressive, I don't know what the MERV rating on this, but it's probably maybe MERV 7. This is gonna stay very clean because I've got that pre-filter. You're still gonna need to check this. I suspect we're gonna wash this every 6 months, but it shouldn't get very dirty at all. And then this filter on the other side is gonna filter the exhaust out of the house. So this right here is sucking air out of the two bathrooms below. And then this down here is supply for the house. And this over here is the exhaust out of the house. Now you're seeing the exhaust pipe is not insulated. It doesn't need to be on the outside because we're pushing basically tempered, conditioned air to the outside. And this is the core right here. So this is doing all the magic for us by exchanging that heat and humidity from the incoming air to the outside air. The beauty of the ERV is that it's not just exchanging heat, it's also exchanging moisture from those two air streams that are not touching but are crossing each other in the core. And so this is a really nice unit. Life Breath, I kind of think of them as the, for lack of a better term, the Chevrolet of ERVs. And Zender, which is the parent company, is kind of the Cadillac or the Ferrari, the Lexus, whatever you want to call it. So this Life Breath, really well priced. You can see super easy to set up. And it's just one notch down in terms of efficiency compared to the Zender. The way that you can kind of generally tell efficiency on ERVs is size, right? The bigger the core, the more ability to move both heat and moisture. This thing too, because we have two of these in this house, I have one here and then one in my lower attic, I'm gonna be able to run it on a pretty low speed. I'll have to check the calcs, but I suspect this is probably gonna run at something like 50 CFM all the time, 24/7, sucking 25 CFM out of each one of those bathrooms and supplying 25 CFM into both of those bedrooms. This makes a really big difference. Let me leave you with this analogy. I love this analogy from Steve Basic, and this is one that I use kind of in my sales presentation to potential clients who are gonna build a custom home with me. I say, the reason why we wanna build a high performance house is pretty similar to why you might want a modern car compared to an old car. How long does it take you to get uncomfortable in your car, especially a modern car built to modern standards and modern codes, when you're sitting in the parking lot? It could even be a relatively mild day. But if you're sitting in that car and the engine's off, you're not getting any fresh air into that car. It doesn't take long at all before you want to crack a window or start the engine. On the other hand, if that engine's running and we're puffing in fresh air into that car, which is basically what this is doing, it's puffing in fresh air, you can be very comfortable taking that Zoom call in your car for an hour in that parking lot, really no matter what the temperature is outside. That's what this is doing for us. We're building a really tight house. We're building a high performance house, a house that's built to, frankly, modern codes and modern standards. This house should have a blower door score below 1 ACH 50. And as a result, we want to dehumidify the air and we want to bring fresh air in. And the other thing I do want to mention is, if you're thinking about order of importance, obviously you're going to put a heating and cooling system in, but don't expect this to be a dehumidifier. This does not dehumidify. In fact, these will raise the humidity in your house over time. So we really need both on a high performance house, especially a house built in any type of humid climate. We want that dehumidifier to separately take care of the humidity of the house, and this is supplying fresh air, but it's reducing the energy penalty. Of course, we could just open the window, right, to get fresh air. We can do that in any house. Even an old leaky house, we can just open the window to get fresh air. But on a house built to modern standards, it's built very tightly. We want that to be built very tightly so that then we can bring fresh air on our terms, and we can put a giant filter on that fresh air to make sure that that air is clean and comfortable, and this is reducing that energy penalty by having an ERV. Guys, thanks for staying put for this long episode. Hopefully you learned something here at the Mechanicals. As I mentioned earlier, this house is gonna be available for you to come tour in November. If you're watching this video after November 2024, you missed it, but come check out future Build Show Lives. I'll put a link in the description of our Build Show Live, and big thanks to our friends at Builders First Source for sponsoring this overall build. We've utilized their digital tools, and you really saw how that made a difference in this particular build by really thinking about where these mechanicals were going ahead of time. Guys, thanks for joining us for another episode of the Reisinger Build.